Hello all, welcome to CodeHub. Let us solve today's lead codes daily challenge. The problem is guess number higher or lower. We are playing the guess game. The game is as follows. I pick a number from 1 to n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. So you call predefined API in guess, which returns three possible results. Your guess is higher than the number I picked, that is, number is greater than pick. That is, the API is going to return -1 if my picked number picked number is lesser than the original num. And I'm going to return the API is going to return 1 if my picked number is greater than num. And the PIP is going to return 0 if the picked number is equal to num. We have to find the number that I picked. So what we can do basically is let us try to take the example 10. The picked number is 6 and let us the n is equal to 10 and pick number is 6. We can try to visualize it, how we can do it. Let us see. So for n equal to 10 and the pick number is 6, we have to return output 6. We will be given the parameter n alone. So basically what we can do is we can call each time guess number from 1, then we can go for 2, and the guess of 2 is also going to give us -1, right? The -1, yeah, it is going to give, sorry, the guess of return the number that I picked. So your guess is higher than the number I picked. So if our guess is 2, and then it is going to return me 1. So the guess of 2 is going to return me 1 since 2 is lesser than 6. So let us try for going for 3. Guess of 3 is also 1, and we will go for further. Then we will try for 6. Guess of 4 is also lesser than 6. So since your guess number is lower than the number that is picked, I picked. So then we will get a 1. So 4 is lesser than 6. So we will not will not pick this 4 as well. Let us go and try for 5. And even in 5, the guess of 5 is 1 because 5 is lesser than 6. Now when we try for 6 itself, the guess of 6 is equal to the pick number 6. So we will return, the guess of 6 will return a 0. So obviously when we get a 0, we know that this is the number that I picked. So the guess number is correct. So easily we can say from this loop from 1 to something. We may not know the pick number, but we can say 1 to pick number. So but can we optimize this? The time complexity for the solution will be an order of n, or I can say it as order of pick number, order of n, will let's say it can be, because we can run a for loop from 1 to n. But can we do this better? Yes, definitely we can do this better. We can see there is a range of numbers and we have to pick only one number. So what we can do is, let us say we are having a number 1 2 then 3 4 then 5, n is 10, right? 5, then 6, then 7, then 8, then 9, and 10. As you can see, these are numbers which are in sorted order, and we want to pick only one such number based on some condition. So like this, if we can see some pattern, then we can obviously apply a binary search. So if we can apply a binary search, it is more optimize than order of n. So what we can basically do is we can have the 1 as low and 10 as high. And what will be the mid value? Mid value is nothing but 5. So the guess of 5 is going to return me 1 because 5 is lesser than 6. So once we see it is lesser than, we want to go for the right half because we need a number which is something greater than that 5. So in this 5, now our low will be 6 and our high will be 10. So the mid will be nothing but 8. So if the mid is 8, the guess of 8 is going to return me -1. Then if it is -1, we need something which is smaller than 8. So uh, we basically move to left half. So the now our range is 6 and 7. So left is 6 and the right is 7. So now the mid value is nothing but 6. So as you can see, the guess of 6 is actually what we needed. So the guess of 6 is 0. So when we reach 0, we actually picked our number correctly. So this is our answer. So basically the time complexity for binary search is order of log n. So this is what we are going to apply here. So this is our amortized solution for this problem. Now let us try to code it soon. So what we basically do is we can have a low which is 1 initially and then high, low which is 1 and a high which is n. And what we can do is while my low is lesser than or equal to high, we can basically do a binary search. First we can find the mid value is nothing but low plus high minus low by 2. Now we can get the guess number. Guess number is nothing but guess of mid, and if my guess number is equal to -1 is equal to 0, then we can just return low. We can just return our mid. This is our answer. Mid is our answer. If my guess number is 0, then we can return my mid. If my guess number is equal to 1, then this is actually lesser than the picked number. So we basically move to right half. So to move right half, basically what we want to do is we can change our low to mid plus 1. So this is what we can do. If my guess number is equal to -1, the number which I choose is lesser than the given number. So we want to find in left half. So my high is nothing but mid -1. So it should not be a not void function. So we can basically return something as -1. So let us see what we are doing. If your guess is lower than the number I picked, that is if our guess is something like 5 and 5 is lesser than the picked number 6, then it is going to return me 1. If it is going to return me 1, so we basically want to move our low pointer which is mid plus 1. Else we can move our high which is mid -1. So now let us try to run the code. So yeah, we get a correct answer. Submit the code. So it gets accepted. So the time complexity for the solution will be an order of log n, the basic binary search. So hope you like the solution and let me know in the comments if there are any suggestions. Let us see in tomorrow's LeetCode Daily Challenge. Until then, bye.